All right, hello. Let's discuss another example of hypothesis testing. So this will be an example of a t-test. We're going to make a claim, we're going to test a claim that the mean FICO score is below 720. So let's record this claim. So this claim is about the population mean. So we say mu is less than 720. And then we're going to establish the hypotheses, HO and HA. The null hypothesis is the one where the equal sign is present. So you may say mu is equal to 720. The alternative hypothesis statement is the statement where the strict inequality is present. So this is where we say mu is less than 720. Now, you may see some examples where we may actually use non-strict inequality symbol under HO. So this is also appropriate because this way you can see the two statements represent complementary events. Mu is either greater or equal to 720 or mu is less than 720. But feel free for simplicity to just use the equal sign only. Now, when you look at the alternative hypothesis statement, you recognize that this is the left-tailed alternative. Left-tailed alternative, since we are testing to see if mu is less than 720. Now, this will be important in the decision-making step of hypothesis testing. Now that we established the hypothesis, the null and alternative hypothesis, let's go ahead and record the data available. So here we've got a random sample of size 101. We have the sample mean, so the mean FICO score in the sample is 703 with a standard deviation of 92. So what this implies is that the standard deviation is the one found in the random sample of 101. So presumably this is the sample standard deviation and not the population standard deviation. So the population standard deviation is not known in this problem. So let's record the data available. So X bar is 703. The sample standard deviation is 92. Now these statistics are based on the sample of size 101. And the level of significance given to us here is 5%. So as you can see, since sigma is not available, sigma is not known, and the sample size is sufficiently large, we recognize that this will be a t-test instead of a z-test. Okay, so just like we discussed the difference between z intervals and t intervals. Same conditions apply to distinguish between a z-test and the t-test. So since it's a t-test, we're going to compute a t-test statistic. So let's calculate a t-test statistic where we standardize the sample mean value. So t is equal to X bar minus mu assumed under HO divided by sample standard deviation over square root of n. So once we plug in the values, 703, 720, and we divide by the standard error of the mean, 92 over square root of 101, we're going to obtain the value of a test statistic. So here I have done all my calculations using Excel. So if you find it convenient, please take a look. If you use Excel for your homework, for your classwork, so feel free to use Excel. If you find it useful, please take a look at the calculations. So the test statistic is negative 1.857, rounded to 3 decimals. If we make a graph of the students' t-distribution with, in this case, n-1, so 100 degrees of freedom. So the graph looks like a bell-shaped, similar to standard normal distribution, centered at 0. And so the rejection region will be in the left tail of the distribution, since we're testing the left-tailed alternative. So we shade 5% of the distribution, the left tail, and then the value that separates the left tail of the distribution, the rejection region, in the distribution from non-rejection region is the critical value. So this critical value can be found in the table. So this is either the value you look up in a table, or you can calculate it using technology such as Excel. So if you like to take advantage of Microsoft Excel, please pay attention. So this is how you calculate this t critical value. So if you use this t.inv, which is the inverse function for the t distribution, this function will output the t value from student's t distribution. You do need to supply the area in the left tail and the degrees of freedom. So the syntax for this function is the following: t.inv. So you provide alpha and you provide degrees of freedom. And so the function will return the t value. So in this case, it returns the critical value, which is equal to a negative 1.660 rounded to 3 decimals. So everything to the left is the rejection region. Everything to the right of the critical value is non-rejection region. Our decision will be determined, will be dictated by data. So data being present in this summarized form of a t-test statistic. So once we place the t-test statistic to the graph, on the graph, so we see that the test statistic is negative 1.857. So it does fall within the rejection region. So therefore, our decision here is to reject the null hypothesis. So this decision was made based on the critical value approach. Another way to make a decision in hypothesis testing is to use a p-value approach. So here we calculate the p-value. Using Excel, you use a t-distribution function. This is, once again, you supply the t-test statistic. This is the degrees of freedom, n-1. And in the last field, you are asking for the probability value by saying that you request cumulative probability. So you answer yes to that question, or true. So you're saying, yes, I want the cumulative probability value as opposed to the density, which is the height of the distribution. So anyways, so the value you obtain is the p-value. What does it represent? What is the p-value anyways? So let's once again look at the definition of the p-value. So by definition, the p-value is the probability that we observe the test statistic at least as extreme as the one found in the random sample already collected. So in our case, what does it mean? So if I state the p-value using the probability notation, it means that we obtain the value of the test statistic, or the value of the sample mean, even more extreme, which means even less than 703, provided HO is true. In other words, provided the true value of the mean is 720. So given 720 is the true population mean. So this statement standardized. So if we standardize the sample mean, the statement becomes the following: probability that t is less than negative 1.857. Okay, so the probability value itself can be obtained by means of technology, and here I demonstrate how to use Excel. But this is the actual meaning of the p-value. If the p-value is small, this means that this outcome would be unlikely if the true mu was equal to 720. So the p-value here is less than 5%. And so for this reason, we reject the null hypothesis, because since our sample data is unlikely under HO, and HO was only our assumption, we would rather reject the assumption than disregard the data that we actually observed. So that was our decision here, once again, to reject the null hypothesis. Since we're rejecting the null hypothesis, that means that we are accepting the alternative hypothesis statement. So we're accepting the claim that mu is less than 720. And so therefore, we conclude that at a 5% level of significance, there is sufficient sample data evidence that the mean FICO score is indeed below 720. All right, I hope you find this helpful. If there are any questions that you have specifically related to the homework problems or any other concepts that you learn in this class, please reach out to me, let me know, and I will address those questions in the video or individually by email. Have a nice day. Take care.